Moving ever closer to the famed unit circle. All right, as we're moving in that direction, we're now looking at evaluating trigonometric functions on the coordinate plane given a point. So it says the given point lies on the terminal side of angle theta. Well, let's define where angle theta is here then. So theta is here. And we find that we've got a point 4, 3, where x is equal to 4, y is equal to 3, and we see this point right here. X is equal to 4, y is equal to 3, and we're asked to find the 6 trigonometric functions of theta. Now, if we imagine or draw a line coming down from the terminal side back down to the x-axis, you can see that this forms a right angle. Now, let's locate our hypotenuse, which is right here, up here, where it's showing ray G. That's a ray. It looks like a line, but it's actually a ray. All right. Well, that's the hypotenuse. Now, what do we know about the legs of this triangle? Well, down here at the bottom, this is 4 units down the x-axis, and this is 3 units up the y-axis, 4, 3. Now, what we don't know is what's the measure of this hypotenuse. But we can find that by using Pythagorean. So let's say that 4 squared plus 3 squared equals, and we're going to call this, rather than c, we're going to call this the radius squared, or r squared. Well, let's see, 4 squared is 16, 3 squared is 9, that's equal to r squared, 25 is equal to r squared, and let's take the square root of both sides of this to where r is equal to 5. And so now we've got a measure for the hypotenuse. Now, we can think about our trig functions. Well, what's sine? Sine is the opposite side of theta over the hypotenuse, and the hypotenuse in this case is the radius, and the opposite side of theta is the distance going up the y-axis, or it equals the y-coordinate. And we can kind of redefine our trig functions based upon what we see in that coordinate plane. And so I can now say that the sine of theta equals the y-coordinate over the radius, or which is still the hypotenuse. The y-coordinate does represent the opposite side, so we're still aligned with that SOHCAHTOA principle. And let's see, what would the cosine of theta be? Well, it'd be the adjacent side, which is the distance along the x-axis, or the x-coordinate. So I could say it is x over the radius, which is the hypotenuse. And then what about the tangent? Well, the opposite side of theta is the y-coordinate, and the adjacent side is the distance of the x-coordinate. And so we can modify our SOHCAHTOA in this way, that the sine of theta, when we're talking about on the coordinate plane, where we got we're in standard position, we got an initial side along the x-axis, we got a terminal side. We can define the sine as y over r, y over the radius, which we have found to be 5, and the cosine is the x-coordinate, the value of the x-coordinate. Well, let's do our trig functions then. So our sine of theta is equal to, what's the y-coordinate? 3. And what did we determine the radius was? 5, or the hypotenuse. The cosine of theta is the adjacent side, which is along the x-coordinate, x value 4, over the hypotenuse 5, or the radius of 5. And what about the tangent? Well, the tangent is y over x. Well, that's 3 over 4. Okay, well, let's see. We might as well do our other 3 trig functions. The cosecant, we know, is just the reciprocal of the sine function. And so if the sine function is y over r, or 3 over 5, then in this case, the cosecant is 5 over 3. All right, that's good enough. What about the secant? Well, the secant is the reciprocal of the cosine function, or we could say it's the r over x, which in this case would be 5 over 4. And the cotangent is the reciprocal of the tangent function, or the adjacent over the opposite, or we might say it another way, it's the value of the x-coordinate over the y-coordinate, or 4 over 3. All right, okay, here we go. We're evaluating trigonometric functions given a point. Let's look at another one right quick. All right, so here we got the same situation. This time we've got a coordinate at -2 and 1. And let's continue with our process right here. I'm going to draw an imaginary line down here between these coordinates here. This forms a right angle at this location. Where is theta? Well, theta is right here. And I'm going to need to find r. I'm going to need to find the value of that radius. But my adjacent side to theta is the x-coordinate, -2. And my opposite side is equal to the y-coordinate, -1. Will be opposite theta. Well, let's go ahead and find the value of our radius, and then we'll begin with our 6 trig functions. So let's see, we've got -2 squared plus -1 squared is going to equal r squared. Well, -2 squared is 4, -1 squared is 1. That's going to equal r squared. 4 and 1 is 5. And if we take the square root of both sides, we're going to find that r is equal to the square root of 5. Okay, now again, what's our sine? Our sine now is going to equal our y-coordinate over the radius. Let's see, what we define the radius as the square root of 5. All right, well then my sine of theta, in this case, is equal to -1 over the square root of 5. But of course, we can't leave that in that form. I've got to rationalize that by multiplying it by the square root of 5 over the square root of 5. So my sine of theta then becomes the negative square root of 5 over 5. I'm going to be running tight on room here. Let's do the cosine. I'm going to do it down here. So the cosine of theta is equal to the x-coordinate, which is -2, over the square root of, over the radius, the square root of 5. And let's rationalize it right quick. Multiplying both by the square root of 5 over 5. I mean, square root of 5, yeah, over square root of 5. And so now I've got -2 square root of 5 over 5. That's my cosine. And then what about my tangent? Well, my tangent of theta is equal to my y-coordinate, my opposite side, -1, over my x-coordinate, my adjacent side, -2. And of course, 2 negatives are going to become 1/2. All right, well, let's go with our cosecant. Well, my cosecant I know cosecant, not CSS, CSC. Cosecant of theta, in this case, is going to be my radius over my y-coordinate, which is the square root of 5 over -1. It's a reciprocal of my sine. And of course, that could simplify to just the negative square root of 5. My secant is going to be the radius over the x-coordinate. My radius is the square root of 5 up. Square root of 5 over -2. Or I might just say negative square root of 5 over 2. And what about our cotangent? Well, our cotangent of theta is going to be the reciprocal. It's going to be the x-coordinate over the y-coordinate. Well, the x-coordinate is -2, the y-coordinate is -1, or 2, which is the reciprocal of 1/2. One thing we want to think about and emphasize right here, when I'm looking at the coordinate plane, first quadrant, all of my trig functions are going to be positive. If it's in the second quadrant, the sine functions are going to be positive, but all the other functions are going to be negative. If we got an angle on the coordinate plane in the third quadrant, my tangent functions are going to be positive, but my sine and cosine functions are going to be negative. And if we're in the fourth quadrant, my cosine functions are going to be positive, but the sine and the tangent functions are going to be negative. All students take calculus. There's a little acronym to help me keep what's going to be positive and what's going to be negative. And when we get to the unit circle, that can be an important thing to remember. And so where is this angle in this case? Well, it's in the third quadrant. So my sine function is going to be negative, which it is. And my cosine function is going to be negative, which it is. But my tangent function is positive, which it is. And then correspondingly, since my cosecant is just a reciprocal of the sine, it's negative. And my secant function is just a reciprocal of the cosine, it's negative. But my cotangent, being a reciprocal of the tangent function, it's positive because why? We're in the third quadrant. And only the tangent and cotangent functions are positive. All the other four are negative. How about that?